Hello, my name is Gabriel, and I will be doing problem number 37 from section 4.5. Problem 37 says that a rectangular box with square base and top is made to contain 1,250 cubic feet. The material for the base costs 35 cents per square foot. For the top, 15 cents per square foot. And for the sides, 20 cents per square foot. Find the dimensions that will minimize the cost of the box. So here we want to draw a picture so we can get a mental reality of what is going on and what we're being asked for. And then we want to separate our given from our unknown. Right now we know that we do not know the dimensions of the box, so thus those are our unknowns. We already have the cost of the base, the top, and the sides. Those are our given, and plus they gave us our volume, which is 1,250 cubic feet. So we want to create an equation that's going to help us solve for the cost of the box. C equals cost. So we put in the cost of the base, x squared. We created a function basically. 15 plus 0.15 x squared plus 0.20 for xy. And the reason why we have a 4 right here is because there are 4 sides on a box, of course, and x and y. X and y would represent the width and the height, so to speak. So we can combine these two numbers. So when we add 0.35 and 0.15, we get 1/2. You can leave it in decimal, but I figure it's easier to differentiate when we leave it in fraction form. We combine this 0.20 times 4, which is 0.8, or basically 4/5 xy. Now, we have our volume equation. We already know that volume equals length times width times height. So now when we create a function out of it, we have x times y, which of course you know on a coordinate plane, these are our y values and x is always horizontal. So we combine those two x's and we get v equals x squared y. We put in the value that they gave us for the volume, which is 1,250 cubic feet. We solve for y, which gives us 1,250 feet squared over x squared. We can take this and put it back into our manipulated equation, so we put this value in for our y. So now we have 1/2 x squared plus 4/5 times 1,250 cubic feet over x squared. And now, since this is another maximization minimum problem, what we want to do is find the first derivative. So after taking the derivative, which is shown here, we get x minus 1,000 x to the -2 cubic feet, which in other words is x minus 1,000 over x squared. So we solved for x. Well, we subtracted both sides by x, and we got negative x equals negative 1,000 over x squared. We multiplied each side by x squared to get x squared out of the denominator, because if not, we may end up with an indeterminate, and we can't have that. So now we have negative x cubed, which equals negative 1,000 cubic feet. We took the cube roots of both sides and ended up with x equals 10 feet. So we now have one dimension. Now we need to find y, which is our height. So we can put this value back into our equation when we solve for y. And we get 1,250 cubic feet over 10 feet, which equals y. When you divide that number by 10, we get 12.5 feet, which is our y. Now, to determine the concavity and behavior of the graph, we can do the second derivative. And that will tell you whether your function is maximizing or minimizing. And in this case, it is minimizing. Thank you.